Looks like I have to make another video about satellites and why they are impossible on the flat Earth and perfectly match the globe. But first of all, I need to explain something about the satellite dishes. Sometimes you see the dish is like this and the LNB is lower than the LNB, and in that position the dish is pointing horizontally, but it receives a signal from upward. Now this simple image of satellite and how we expect to receive it. So we point the dish with a elevation angle, and we're not saying that this satellite is in orbit or in balloon. We just don't know. We don't see it. We don't know what it is exactly. But we know that it is on the equator, somewhere on the equator. Let me show you this. Site here is called the dish pointer, and you select any satellite from this menu, and then you drag this to your location. So as you can see, it's on the equator. If you go south, it will be pointing north to the same location. Alright, so now we know that the satellites are somewhere above the equator. And on a Gleason map or on a globe model, if you measure the distance from a location to the equator, they are the same. So we know the distance to the equator. This way we can triangulate the satellite using this angle. Now some people would say this could be a transmission tower or something like that. Well, you cannot find anything like that. And some people say, yeah, it's the the cell towers. But in a whole city, like in a 20-kilometer diameter, you'll find the elevation angle the same. So this means it gotta be so far away, yes, on the equator. And then so I went to look for more videos, and I found this. Yeah, the ionosphere. Some people say, okay, so the satellites are not hanging in a balloon or something, but it's some big dishes somewhere transmitting to the ionosphere, and then we receive it. But according to my calculations, the ionosphere must be around 3,000 kilometers high and down to a couple hundred kilometers. In fact, the distance will be half the distance to the equator. You get the distance by multiplying the latitude line by 112 kilometers divided by 2, because this is where we are receiving the signal, not from here. And after that, the height will equal the distance multiply the inverse tan of the elevation angle. Now if you do that from different location, you will not get the same altitude as I'm showing here. No, the altitude varies for the same satellite. So it's very easy to calculate the altitude of the satellite if it was a physical object above the equator, or if you're calculating the height of the ionosphere, if it is indeed reflecting from the ionosphere. Now on the globe it's a little bit difficult, and I showed it before in another video, but anyway, I made things easier for me on a spreadsheet. This is the inputs are here. You get the latitude line and the elevation angle from here. Your location, this is the latitude, and this is the elevation angle. So you pick different places, and preferably it should be exact south or exact north to the same satellite. So this is what I did. Single satellite, the same satellite from different latitude gave me different elevation angles, and I used these numbers for the flat Earth and for the globe. And this is what I get. The distance to the equator is going to be the same, because as I said, if you measure south, due north, you get the same distance to the equator. Now the satellite altitude here is 5,300, 5,300, 480, 42, 29, 15, and so on. It's radically changing. And for the globe model, it's 32,000, 35, 34, 35, 36, almost 35, and so on. And you can see that the changes are minimum or smaller, not as in the flat Earth. So I'll put a link up here for the previous video that explains how I get the elevation or the altitude of satellites on the globe. It's a little bit long to do in this video. I just wanted to make this video to address this issue, because when I made the previous video, I had no idea that some people say it's the ionosphere that it's reflecting at, and I've seen many old videos like a year or 2 years ago by many flat earthers making the same claim. So I just wanted to address it here and point to the older video. Thank you all for watching.